Validating that your system adheres to its security policies is not a trivial task, and often several anti-patterns creep in that you need to be aware of when you're thinking about this. The first is that you cannot rely on a password policy alone. You can be compromised obviously by having too weak of passwords, but also by having too strong of ones where people just write them down on post-its. Right? So relying on passwords alone is not a sufficient security policy. Next, we can't make assumptions about how the firewalls and other countermeasures we have will protect us in our entirety. Right? And this is again where defense in depth steps in. We need to have multiple layers of countermeasures, so simply relying on a firewall is not enough. Next, having an update policy that keeps your hardware, operating systems, libraries, and frameworks all up to date is also not sufficient to guarantee security. While this is a good way to update your system and get new security patches rolled in, there's always going to be other security defects in there that you need to protect against. And finally, relying on penetration testing alone for security is also not sufficient. So while penetration testing is a good validation approach, it is not sufficient to completely verify the security of your system. Rather than relying on these simplistic anti-patterns and assuming that your system is secure, we need to thoughtfully and thoroughly validate the security of our system in a controlled and systematic way. There are many approaches we can use to validate the security properties of our systems. The first is code review. While we're writing code is the best time to look at our change and evaluate whether or not it introduces new security vulnerabilities to our system. And by having other engineers also inspect that code at the time when it's fresh in our mind, we can help improve our chances of detecting security problems. Next, we have static analysis approaches. These are tools that run against our source code to detect for known vulnerabilities. We can also use them to perform data flow analysis, which will go through and check to see if sensitive information can leak out of our system and warn us if that's the case. Executing programs against our systems to dynamically validate their security properties falls under the realm of dynamic analysis. And this can include running malware bots against a program or automated fuzzing techniques. Fuzz testing is a black box security testing technique that is really complementary to the other techniques that we're talking about here. One thing that's nice about fuzz testing is it's able to find other classes of security faults that often evade these more code review based and static analysis based testing approaches. So what fuzz testing does is it takes your system and identifies the main points of entry into the system. So these are the places where data flows in and out of the system. And what fuzz testing does is it then goes and generates wide varieties of data against these endpoints. Now this data isn't purely just noise. Right? So the fuzz testing approach might know something about the schema for these endpoints so that it can generate semi-random data that tries to trick the system into accepting requests that it should otherwise reject. The types of data that fuzz testing approaches will really vary from program to program. Some systems might go and try to get in through the network, while others will try to access databases, and still others might try to invalidate the file system or attack the operating system itself. The main benefit of fuzz testing-based approaches is that they can be applied to any system in an automated way. The type of fault that we most commonly see when we're fuzzing a system is a program crash, and these crashes are unambiguously program failures. When we go and fix these underlying causes that cause the crash, we often find that there are underlying security issues in there as well that get fixed along the way, and this is a great benefit of using fuzzing-based approaches. One specialized form of dynamic analysis is called penetration testing, and this is where users will try to defeat the security policies of our systems using their own creative means. Now it's important to note that this can show the presence of security faults, but certainly not the absence. And it's also important to not rely on this method exclusively. So when teams actually do this, you'll hear the term red team being used, and the red team are the penetration testers that are trying to break into your system. Often you'll also have a blue team, that's your network operations team, that will be trying to detect the attack. More sophisticated forms of penetration testing will also have the red team attacking your system when the blue team doesn't know the attacks are coming, to see how they can verify and respond to those attacks in real time.